Okay, we are going to cover section 1.7. We're going to be looking at a couple examples here. So first of all, example 1. We got negative 3x plus 5 is greater than negative 7. We want to solve this, and then we want to write our answer in what's called interval notation. So we're going to subtract 5 across the inequality. And if y'all remember from subtracting across inequalities, the inequality does not change direction. It stays pointing the same way. It's only if you multiply or divide by a negative that the inequality flips direction. So in this step, we're going to divide by negative 3. So now we are dividing by a negative. So the inequality flips. So we get basically x is now less than. Negative 12 over negative 3 is going to go down to positive 4. In an interval notation, we would write this as negative infinity up to positive 4. So we want all x's less than 4, so that's 4 on down to negative infinity. We use open brackets on infinities always, and then it's not okay to equal 4, so we would use an open bracket on 4. And this is what we would call our interval notation. So we want to express our answers to our inequalities in interval notation. So we're going to make up an example real quick that does a bunch of interval notation cases. So this will be interval notation. So for interval notation, let's say we have x less than negative 3, x less than or equal to 5, x greater than 4, x, let's say, greater than or equal to negative 2. And let's say x is between 1 and 4. Say x is between or equal to 2 and 5. And say we got negative 10 is x greater than negative 10 but less than or equal to 12. So we would write this one in interval notation. This would be negative 3. It's all x's less than negative 3, so it's negative 3 on down to negative infinity. Infinities always get open brackets, and it's not okay to equal negative 3, so we're going to put an open bracket on that as well. This one, x is less than or equal to 5, so it's negative infinity up to 5. It's not okay to equal a negative infinity, so we put an open bracket on it, but it is okay to equal positive 5, so positive 5 gets a square bracket. Here we have x is greater than 4, so that would be 4 on up to infinity. In an interval notation, the smaller thing or the smaller expression needs to be on the left, the larger one needs to be on the right. Infinities always get open brackets. It's not okay to equal 4, so we put an open bracket on it. And here we got x is greater than or equal to negative 2, so it's negative 2 on up. Infinities always get open bracket. It's okay to equal negative 2, so negative 2 gets a square bracket. So that's our first kind of block of examples. Then for the next ones here, x is between 1 and 4. It's not okay to equal 1. It's not okay to equal 4, so we use open brackets on either side. For this one, x is between 2 and 5. It's okay to equal 2, so 2 gets a square bracket. It's okay to equal 5, so 5 also gets a square bracket. On this final one, x is between negative 10 and 12. It's not okay to equal negative 10. It is okay to equal 12. And we get our expression looking like that. So moving along, next example, want us to figure out what's going on with 4 minus 3x is less than or equal to 7 plus 2x. We want to answer in interval notation. So to solve this, I'm going to get all the x's on one side, so I'll subtract 2 x's across. I'll subtract 4 across. Negative 3x take away 2 x's is negative 5 x's. It's less than or equal to 7, take away 4, which is 3. This step I divide by a negative 5. Since I'm dividing by a negative, the inequality flips direction, and I get x is greater than or equal to negative 3/5. So this will be negative 3/5 on up to infinity. Negative 3/5, it's okay to equal negative 3/5, and infinity always gets a open bracket. So we say, all right, there is our solution to that one. Remember, for inequalities, flip only if we multiply or divide by a negative number. So if you add or subtract, the inequality direction stays the same. If you multiply or divide by positive numbers, the inequality direction stays the same. Only when you multiply or divide by a negative does the inequality direction flip. So next we're going to look at example 4. So this says, suppose we have this type of inequality where we have negative 2 is less than 5 plus 3x is less than 20. We want to solve this and answer in interval notation. So our goal is to get x by itself in the center. So this is going to work pretty much like a regular equation, but you just have kind of an extra slot that you're going to add or subtract stuff to. So if I want to get x by itself, I need to subtract the 5 here. And normally you only have one other place that you would need to subtract 5 from. But since we have kind of this triple inequality here, we're going to have to subtract 5 from all 3 places. So we'll get negative 7 is less than, they'll cancel here, we'll say 3x. That's going to be less than 20 take away 5 is 15. Again, I subtracted. Subtracting does not change the direction of the inequality. So next up, if I really want to get x by itself, I divide by 3. So I have to make sure I divide by 3 in all 3 places. So now x is by itself because the 3's cancel. So we get x is bigger than negative 7/3, but it's less than 15 divided by 3 is 5. So we'll get basically an interval notation. This is negative 7/3 up to 5. It's not okay to equal negative 7/3. It's not okay to equal 5, so we leave them both with open brackets. Okay, then for the next example, these are going to get a little trickier. We form what are called polynomial inequalities. These work a little bit different. So this is going to be example 5. We say, suppose we had x squared minus x minus 12 is less than 0. For these, we're going to have to build a plus or minus chart sort of thing. And the tip-off that you're going to do this is you see that the x is squared. You have x squared involved. So first, we're going to factor this. So this is going to factor as x minus 4 times x plus 3. Next, we're going to find the zeros of the expression. So to do that, I'm going to set each individual factor equal to 0. We'll solve those for x. Then, once we get those, we're going to use those numbers to build a chart. We're going to have a negative infinity up to the smallest number up to the next number, then the next number up to infinity. So we have to order these, or it's negative infinity. It's got to be negative 3 because that comes on the number line before positive 4 does. In these charts, we're going to create a couple of different blocks. We're going to choose something called test points. These are easy to work with numbers that are inside each of those intervals. So I need a number between negative infinity and negative 3 that's easy to work with, so I'll choose negative 4. I need a number between negative 3 and 4 that's easy to work with, so we'll go with 0. And I need a number bigger than 4, so between 4 and infinity, we'll choose 5. What we're going to do with those numbers is we're going to substitute them into the x's in each of these factors, and we're going to keep track of the sign that that x makes that factor. So I put negative 4 in. Negative 4 minus 4 is negative 8, which is a negative number. When I put negative 4 in here, negative 4 plus 3 is a negative 1, which is also a negative. Negative times a negative is positive. So next I'll put 0 in. 0 minus 4 is a negative. 0 plus 3 is a positive. Negative times a positive is negative. Put 5 in. 5 minus 4 is positive. 5 plus 3 is positive. Positive plus a positive is positive. Okay, so we got that. So now what we need to do is we need to see which region do I want to keep. I want to keep where this thing is less than 0. So I think what type of numbers are less than 0? Well, negatives are less than 0. So I want to keep this interval here that has the solutions being negative down there. So our answer will be the negative 3 up to 4 interval, because those x values make the expression less than 0, which makes the expression negative, and where the expression is negative, negative numbers are less than 0. So that's our solution to that one. We're going to look at a couple more types of these that build the table, and then that'll be section 1.7. So next example, this is example 6 in the y'all's textbook. This is 2x squared plus 5x minus 12 is greater than or equal to 0. We want to solve this and answer in interval notation. So step 1, we have to factor this. So we'll factor this as, let's see, 2x and an x. 2x times 4 is 8, and a 3. 8 minus 3 is 5, so plus 8 minus 3. So here's our factored form. We need to figure out the zeros. So I'll set each of those factors equal to 0 individually, and I'll solve each of those for x. So I get 2x equals 3, divide by 2. X is 3 halves. Over here, the 4 comes over as a negative 4, and I get x is negative 4. So I use these numbers to break up, get my intervals for my chart. Negative infinity to the smaller number, negative 4, that comes first. Negative 4 to the next number, which is 3 halves, is next. Then 3 halves up to infinity. I'm going to choose a test point to use for each interval. So I'll use negative 5 from here, I'll use 0 from here, and I'll use, I guess, 3 from there. And then we're going to plug our numbers into these two factors, and we're going to keep track of what sign is plugging the numbers in there, what sign is that making the factors. So I put negative 5 in, I get negative 10 minus 3 is negative. Negative 5 plus 4 is negative. Negative times a negative is positive. When I put 0 in, 0 minus 3 is negative. 0 plus 4 is positive. Negative times a positive is negative. When I put 3 in, 2 times 3 is 6. 6 take away 3 is positive. 3 plus 4 is positive. They're both positive, so you end up with a positive answer. Now, it's okay to be greater than 0, which greater than 0 means positive numbers. So that tells us it's going to be these two intervals. But this time, it's also okay to equal 0. So equal 0 means we need to include these zeros values of 3 halves and negative 4. And the way we can include those numbers is by putting a square bracket on the end of the interval. So we need the first interval, but it's okay to equal -4. So we say, put a little square bracket there, says it's okay to equal -4. We see we have a bunch of skipped values here. So when you have skipped values, you're going to use a union. Then it's okay to equal 3/2. So we use 3/2 with the square bracket on up to infinity. And that will be our answer for that particular one. Okay, so we got a few more examples. So example 7. This will be a projectile height. So we say a projectile is launched from the ground. Okay. With an initial velocity of 96 feet per second. And we'll say, when will the projectile be greater than 80 feet above the ground? So when is it greater than 80 feet above the ground? Okay, so our projectile equation is S equals -16t squared plus v naught t plus s naught. They told us that we launched it from the ground, so launching it from the ground says s naught's going to be 0. V naught, they told me the initial velocity was 96. So our projectile equation is this. And s naught's 0, so we don't add that. So again, v naught is the initial velocity, s naught is the initial height. If we're launching it up from the ground, the initial height is 0, and they told us initial velocity was 96. We want to know, when is the projectile greater than 80? So we have 80 here. And we want to know, when is the projectile value s here, when is that bigger than 80? That's the projectile's height. So the projectile's height, s, is equal to -16t squared plus 96t. I need to move all these terms across the inequality. So I'll be adding the 16t squared across. I'll be subtracting 96t. Neither of those is multiplying or dividing by a negative, so I do not need to change the direction of my inequality. This is what I'm trying to figure out. All these are divisible by 16, so I'm going to go through and divide the whole equation by 16 to make the numbers easier to work with. So I get t squared minus 6t plus 5. This is going to be still less than 0 because I'm dividing by a positive number, so the inequality direction does not change. I factor this so I can start building my table. I get t minus 5 and t minus 1. So this says t is going to equal 5 or t is going to equal 1. So t equals 5 or t equals 1. So I go to build my table. So I have a negative infinity to the smaller number 1. I have a 1 up to 5. Then I have a 5 up to infinity. Okay, let's see here. So I need a number between negative infinity and 1, so we'll use 0. I need a number between 1 and 5, we'll use 2. Something between 5 and infinity, we'll use 6. We're going to be plugging them in for these t values here and keeping track of what's going on with each of those factors. So if I put 0 in, 0 minus 5 is negative, 0 minus 1 is negative, negative times negative is positive. If I put 2 in, 2 minus 5 is negative, 2 minus 1 is positive. So we're negative there. If I put 6 in, 6 minus 5 is positive, 6 minus 1 is positive, everything's positive, so we're positive there. So I want to know, where's this expression less than 0? So strictly less than 0 means where is it negative, which means times in this interval are what we want. So our answer to that one will just be 1 up to 5, because that makes the expression less than 0. Okay. So final two examples are going to be what we call rational inequalities. So this will be example 8. They give us 5 over x plus 4 is greater than or equal to 1. So step 1, we got to get everything on the same side and got to get our inequality compared to 0. So we're going to scoot the positive 1 across the inequality as a negative 1. We'll get 5 over x plus 4 minus 1 is greater than or equal to 0. Now, I need to combine these together, and I can't do that until this has the same denominator as this. So in order to make that happen, I'm going to have to multiply the 1 in the top by x plus 4 and down in the bottom by the same x plus 4. This makes the denominators have the same size. So now that they have a common denominator, we're able to write this all out as the expression over x plus 4. So we have 5 minus 1 times x plus 4 is minus x plus 4. We'll distribute the negative. And we get 1 minus x over x plus 4 is greater than or equal to 0. So this is the simplified form we need to get down to before we start figuring out who are we going to use for our chart. We'll look at the 0 expression that make the 0. This is going to make the top of the expression 0. So the top of the expression is 1 minus x. So if I put a 1 in here, we get 1 minus 1. Let's just set it equal to 0. 1 minus x is the top of the expression. We set it equal to 0. I add the x across, and we get 1 equals x is our 0. That makes the top 0. We have an undefined. This will make the bottom equal to 0. So the bottom is x plus 4. X plus 4 equals 0. We slide the 4 across, so x equals negative 4 will be my undefined. So I'm going to build my chart. Negative infinity to the smaller of these two numbers, so negative infinity up to negative 4. Then I get negative 4 up to 1. Then I get 1 up to infinity. So I'm going to choose an easy to work with number. So negative 5 from the first interval, 0 from this interval, 2 from there. We're going to plug into the x in the top of the division, and we're going to plug into the x in the bottom of the division. And I'm going to keep track of what sign in the fraction, what's the sign at the top of the fraction, and what's the sign at the bottom of the fraction. So then I put negative 5 in here. 1 minus a negative 5 is 1 plus 5, so that's a positive 6. When I put a negative 5 down here, negative 5 plus 4 is negative. Positive divided by a negative is negative. Then I put 0 in. 1 minus 0 is positive. 0 plus 4 is positive. Positive over positive is positive. When I put 2 in, 1 minus 2 is negative. 2 plus 4 is 6, which is positive. Negative over positive is negative. Okay, I want to know where this expression is bigger than 0. So bigger than 0 means where is it positive? So we're going to keep this, this range of x's. It's okay to equal 0, so I need to include x equals 1. I don't include x equals negative 4 because that made the expression undefined. Undefined is not 0, but we do have a 0 over here at x equals 1. So I'm going to get my interval. I don't include negative 4. but it is okay to equal 0, and my 0 is at 1, so I'm going to put a square bracket there, say negative 4 up to 1 is my solution. Okay, so final example is going to wrap up section 1.7. So this is going to be example 9. It's another rational inequality. Suppose we had 2x minus 1 over 3x plus 4, and that's supposed to be less than 5. Want to solve that and answer in interval notation. Step 1, the 5 comes over as a negative 5. I'm going to need to find an LCD, so I'm going to give myself a little bit of space and put the inequality out there. And what's going to go in here is going to be a 3x plus 4 over a 3x plus 4. So when I combine these up, I get 3x plus 4 there. We get 2x minus 1. And the negative 5 here is going to distribute. So we'll get negative 15x minus 20. So we go through and combine our like terms. So I guess actually it'll be a... So 2x's take away 15x's is negative 13x's. Negative 1 take away 20 is negative 21. Down here we have a 3x plus a 4, and we want to know where is that less than 0. So to find the 0, I'm going to set the top equal to 0, so I'll set negative 13x minus 21 equal to 0. Scoot the negative 21 over. Divide by negative 13. So I get x is negative 21/13. Then for my undefined, I'll set the bottom term equal to 0. We get x equals negative 4/3. So I need to know which of these is actually smaller, so when I go to build my chart, I include them correctly. So negative 21/13 is about negative 1.62, about. And negative 4/3 is negative 1.33, about. So it's going to be negative infinity. The negative 21/13 is more negative. So up to negative 21/13. Negative 21/13 goes up to negative 4/3. And negative 4/3 goes up to infinity. So I'm going to choose test point, keep track of what's going on with the division. So for my test point, I'm going to use something more negative than negative 1.6. So I'll use like negative 3. I need something between negative 1.6 and negative 1.3. So I'll use negative 1.5 for here in the middle. Then I need something bigger than negative 4/3, so I'll use 0. We're going to be plugging in for the x down here and plugging in for the x up here. When I put negative 3 in, negative 13 times negative 3 is positive 39. 39 take away 21 will be positive. And 3 times negative 3 is negative 9. Negative 9 plus 4 will be negative. So the initial interval is negative. When I put in negative 1.5, let's see what that makes the top. The top becomes negative 1.5, so the top is negative. When I put negative 1.5 into the bottom, I end up with negative 0.5, so we're negative over negative here, which is positive. Then I put 0 in the top, I get negative 21, which is negative. Get 0 plus 4, which is positive. So we end up being negative there. I want to know where my whole expression is less than 0. Types of numbers that are less than 0 are negatives. So that would be this interval and this interval, and we get this expression here joined up with this one here. Okay. So that's going to wrap it up for section 1.7. So we'll stop this video here.